All right, here we go. Week 5, 5.2. This is about polynomial functions. Now, you might wonder, why is it called polynomial functions? Well, we just call them polynomial functions, but it's all about exponents. So in this case, it's about adding and subtracting polynomials, which gets us going with exponents for sure. And the thing it gets us going with doing is combining like terms. So we have to be really good at combining like terms. And the way we identify whether or not we can combine like terms is if the exponents on like variables or common variables are the same. So in this first set of 5 problems here, all we have to do is combine like terms. So we can look at A and see that A, they're both just x's. So if they're both just x's, they have the same exponent of 1. So we can combine those. Negative 3 plus 7 is 4. So this is just 4x. Okay, B, we have an x, we have a 3x squared. So this is a great example of two terms that are not like terms because an x is not the same as an x squared. So we can't combine like terms on this one. So this one is as simplified as it gets. This third one, C, they're both x to the third. So we have 9x to the third plus x to the third, or 1x to the third. So this is 10x to the third. It's hard to say after a while. And then the next one is one that gets into having multiple things that we need to combine. And when we have multiple things that we need to combine, I like to sometimes use a highlighter to identify what I'm combining. Oops, I don't want to do a little dot. So we have that, 11x squared goes with the positive 2x squared. Notice how I included that positive sign in there. And then we can even switch up colors if we want. And we've got a positive 5 and a negative 7. So this is a great way to keep track of what needs to be combined, and it's also a great way to keep track of symbols or signs, positive and negative, right? So making sure we include those signs in there is going to go a long ways to helping us combine like terms properly. Okay, so in this case, the green is 11x squared plus 2x squared, so that's just 13x squared. Notice how the x squared isn't changing at all. It's just the coefficient that changes. And then we have positive 5, negative 7, so that's negative 2. Okay, and then the last one, kind of wondering why I put this in here, but it's got a whole bunch of fractions, and let's just ignore those fractions until we need to worry about them. So when we're combining like terms, we don't need to worry about the fractions until we actually start to do the work of combining things. But let's do this. Let's use our highlighter again. We've got a 2/5 x to the 4th. I see another x to the 4th term here, so I'm going to highlight that with the plus sign. And then I'm going to switch to another color. I can see I've got 2x to the 3rd terms, so I'm going to highlight those. And then might as well just do another color for fun here. Negative x squared. All right, so if we start to combine like terms here, we have 2/5 and 1/10. And we have to combine those. So let's remember that I'm going to go down here maybe and do 2/5. I want to turn it into tenths in order to combine like terms because I have to have a common denominator, right? So I'm going to multiply by 2. So we have 4/10. So that's 4/10 x to the 4th. Okay, and I'm going to add 1/10 x to the 4th. Okay, so that's 5/10 x to the 4th. And then we can simplify that a little bit, so it ends up being 1/2 x to the 4th. Wow, lots of work for this one. Okay, so let's look at the green ones. The green ones, we have 2/3 x to the 3rd and negative 1/6 x to the 3rd. So we need to turn the 2/3 into something with a 6 in the denominator. So we have 2/3. We're going to multiply by 2 again. Now, in both these cases, we multiply by 2. That's not always going to be the case. Sometimes you might have to multiply by a different number. So we end up with 4/6. So we have the green ones, we have 4/6 x to the 3rd plus, less than 2 plus. Let's do minus because it's negative. So we have minus 1/6 x to the 3rd. So we end up with 3/6 x to the third. Well, both of these end up being 1/2, which is interesting, but just coincidental. All right, so I'm going to get rid of my work down here on the bottom so that I can have more room, so that when I combine like terms. So when I combine like terms, the orangish colored ones, that was the 1/2 x to the fourth. The green ones, 1/2 x to the third. And the pink one, all by itself, x squared. Okay, so that's how we combine like terms with this one when we have to do some extra work. One thing to notice in this case, actually in all of the cases, but in this one in particular, notice how the order of the terms is based on the exponent, and we're going in descending order. So we're starting with the largest exponent and going to the smallest one. And that's generally the way that we like to write things. Now, things aren't always going to be written that way, but someday you might run into a teacher that really requires you to have it be written a certain way. So you might want to make sure you know that generally we do things in descending order when it comes to polynomials. All right, so adding and subtracting polynomials. So adding and subtracting is just another way to do combining like terms. But in this case, we have these parentheses in here because this represents one polynomial here, and this represents a second polynomial here. And that's the only reason that the parentheses are there. It's just showing that, hey, we've got two separate polynomials that we're adding together, and so we want to differentiate them using parentheses. But when we are adding, if you see this plus sign here, the cool thing about adding polynomials is we can get rid of the parentheses and not have to change anything else. Okay, so I can rewrite this as 7x to the third y minus xy to the third plus 11 plus 6x to the third y minus 4. Okay, so that's unique to addition. When we do subtraction, we're not going to have it that simple. Okay, so you're going to have to do a little extra work when we have subtraction, but when we're dealing with addition, we can just get rid of the parentheses and combine like terms. Well, we got multiple variables here, so we have to be careful. Each variable needs to have the same exponent. So, and this one's trying to trick you right off the bat because we've got this, which is 1, and this goes with it because the x has a 3 on it, the y has a 1 on it. Now that's trying to trick you because we have this other one, negative xy to the third. They use a 3 on the y as a way to trick you because they want you to think it's the same, but it's not, because the x has a 1, the y has a 3, whereas the two pink ones, the x has the 3 and the y has the 1. So we can't combine that one with the other two, but we can combine the 11 and the negative 4. All right, so we're going to go ahead and combine our terms here. So we have 7 plus 6 is 13, so this is 13x to the third y. And then the next term in order here would be the negative xy to the third, I suppose. Generally speaking, we end with the what's called a constant, or just an individual number, which is going to be the result of 11 minus 4, so it's plus 7. Okay, so be careful with stuff like this, where you have multiple variables. It's very easy to try to go too quickly and not combine the right things. All right, so this was a case where it's all written out in like equation form, adding two polynomials together. Sometimes we might use words instead of symbols. So it just says add this and that. Well, same thing. So we can just replace this and with a plus sign, and we can get rid of the parentheses. So we have 11x to the third minus 12x squared plus x minus 3 plus, there's no sign with the x to the third, but it's positive, so we write plus, minus 10x plus 5. All right, so let's get to highlighting. So we have 1, 2, 3 things that we need to highlight, and I just quickly looked through to notice that I have 2x to the third terms. I have 2x terms. And then I have two constants. Okay, so the negative 12x squared, that's the only one of squared terms, so we don't have to do anything with it, but we're going to simplify the x to the third, so that becomes 12x to the third. And then we have the x squared is going to come next, so 12x squared minus 12x squared. And then we have 1 minus 10, so that's negative 9x. And then negative 3 plus 5, so that's 2. All right, simple enough. Combining like terms. So I said before, subtraction is a bit different. And it is, because what happens with subtraction is we're subtracting everything inside the parentheses. We're not just subtracting the 2x to the third in this case. So we're subtracting 2x to the third, we're subtracting negative x squared, and we're subtracting 1. So what happens with parentheses is the signs change on everything. So let's change this to a plus. It makes that a negative 2, a plus here, and a negative 1 here. Okay, so then we'll rewrite everything. So we have 2x to the third plus 8x squared minus 6x. So nothing changes in the first polynomial, but the second one is where everything changes. And I wrote a bunch of stuff on here to indicate what's changing, but there's a really simple way to remember. Whenever we're subtracting a polynomial, the signs of each term just change. Okay, so it was positive 2x to the third, so it becomes negative 2x to the third. It was negative x squared, so it becomes positive x squared. And it's positive 1, so it becomes negative 1. Okay, so the signs just change from positive to negative or negative to positive, depending on which way we have to go. All right, so let's combine like terms. So we have 2x to the third, negative 2x to the third. Well, that's nice. Those things are going to cancel each other out. So let's just do this. We get rid of them. All right, so let's look at another one. So then we have a squared term. Still, notice I'm keeping that sign in the highlighting. And then nothing else can get combined because we have a negative 6x, we have a negative 1. Those are two unique things, so we have to just run with what we've got here. So we've already canceled the negative and the positive 2x to the third, so all we have is 8x squared plus 1, so that's 9x squared, minus 6x minus 1. So this one wasn't actually that bad once we got over the fact that we just changed all the signs. All right, here we go. Another one. Oh, subtraction and multiple variables. And they're trying to trick us for sure in this one because look at that, 5b squared a. And what do you notice? It's the only one that isn't in the same order as everything else. Silly book, trying to trick us. All right, so instead of doing that, changing this to a plus sign and then changing the signs on all those with symbols to kind of mess it up, I'm just going to do it as I go. So here we go. Ready? And what I'm going to do as well is I'm going to flip that 5b squared a around. I'm going to call it 5ab squared, just so it's in the same order as everything else. I don't know why they do that. It's kind of annoying. Here we go. 9a squared b squared plus 6ab. Let's make a better b there. Minus 3ab squared. Okay, so here we go. Minus 5ab squared. Okay, so 5b squared a was positive, so it's minus now, right? And so now we have plus 2ab, but we're going to make it minus 2ab. Minus 3 becomes plus 3. Minus 9b squared becomes plus 9b squared. All right. Let's combine like terms. So here we go. What do we have that's like terms? Is there another a squared b squared? No. So the 9a squared b squared is all by itself. Is there another ab? Yes. So let's highlight the 6ab and the negative 2ab. Let's get another color. So the next one we have ab squared. Well, they're right next to each other. So look at this. We can just do this craziness. Highlight the whole thing. And then there's a 3. There's no other constant, so we don't have another number to combine that with. And there's a 9b squared. There's no other 9b squared. So there we go. We got everything we need. So now we just have to write them all down. And let's do this. We're going to put this one first. And then we're going to go with green. So we have negative 8, negative 8ab squared. And then we're going to go with the red ones. So we have plus 4ab. And then we're going to go with 9b squared. And then we're going to go with 3. Okay, so there we go. That one was a little bit more complex because it was subtracting a polynomial where we had to change all the signs in the second polynomial. And we had a term that was backwards they were trying to trick us with. And then we had multiple variables, which is a little bit confusing sometimes, especially when all the exponents are very similar. Or all the exponents are the same, bunch of 2's, right? Okay, your assignment is down here. Remember, pay close attention to this where it says odd. So 13 through 19, odd. Don't do them all. And then 54 through 60, even. So don't do all those either. Now, I will say these 13 through 19 here, you are going to be evaluating. So you have to plug stuff in, which is something I haven't shown you in this lesson, but we've done plenty of it this year, so I'm confident that you're able to do it.